Okay, this is on determinants. And multiplicative inverses. Determinants and multiplicative inverses of matrices. Okay. First, this is one of my all-time favorite words in math. Try saying that. Multiplicative. Try saying it. Multiplicative. Okay? Doesn't it just... It's great. It's a great word. Okay? Multiplicative inverses. Okay. Each square matrix. Now, when they talk about a square matrix, remember the matrix with rows and columns. A square matrix would be like a 2 by 2, a 3 by 3, a 4 by 4. So each square matrix has a determinant. Okay, each square matrix has a determinant. And the determinant is a value associated with that matrix. So when you figure the determinant, it's just going to be a value or a number. Okay? So in the directions they will say find the determinant. And then we're going to use determinants down the road to solve like 2 equations, 2 unknowns. You can use it to solve 3 equations, 3 unknowns. Okay, find the determinants. Okay, on this first one, a matrix had a bracket around it. Determinants have straight lines. Okay, so and it's a 2 by 2. And if you just listen, you can write it. First row across is 6, 2. Second row across is 4, 8. Okay, make sure it's got straight lines, not brackets. Okay? The value of a determinant. Okay, everybody watch up here for a minute. On the determinant, you multiply going down the diagonal to the right. Okay, so you'd multiply that, would be 48. And then you subtract the product coming back up. So you'd subtract 8. And the value of that determinant would be 40. You always multiply down the diagonal to the right, and you subtract the product coming back up. Okay? Let's try another one. Say I give you a 2 by 2. First row across is 7 and 9. Second row across is 3 and 6. Okay, so you're going to multiply down the diagonal to the right, would be 42, and you're going to subtract the product coming back up. Okay, so if we subtract that, would be, what, 27, and should be 15. Okay, take your time on the arithmetic. Okay, one more example on that. Another 2 by 2. First row across is 0, negative 2. Second row across is 8, negative 6. Multiply down the diagonal to the right. Should be 0. And subtract the product coming back up. So it's minus a negative 16. Should be 16. Okay? Okay? So that's a 2 by 2 determinant. Okay, now let's do a 3 by 3. Okay? Find, and on this one I'm going to show you more than one method, and on the test I could give you one problem and say work it this way, this way, this way. You should get the same answer, okay, but I'm not just grading your answer. I'm grading your method. Did you understand the method? Okay? So on this one, find the determinant of a 3 by 3 using, and this method is called expansion of minors. Okay, find the value of this determinant of the 3 by 3 using expansion of minors. Okay, this is a 3 by 3. First row across is 8, 9, 3. Second row across is 3, 5, 7. Third row across is -1, 2, 4. Okay? Okay, everybody look up here for a minute. When you do this on expansion of minors, a 3 by 3, above each column you're going to put signs, and it always starts with a positive, and it's going to alternate. Positive, negative, positive. So, if you have a different colored pen, it's a positive, negative, positive. If it was a 4 by 4, it'd go positive, negative, positive, negative. Okay? When you expand it by minors, that means you're going to go from a 3 by 3 down to 2 by 2s. Okay? You take what's in this first row, first column, okay, and you wipe out that row and that column and take it times the 2 by 2 that's left. So you take the 8, you wipe out the row that 8 is in, the column that the 8's in, and the 2 by 2 that's left, and it's a determinant, so it's 5, 7, 2, 4. Okay? And then this minus, and then you wipe out and then it's 9. You wipe out the row that the 9 is in. Okay, so you're going to wipe out the row that the 9 is in, and the column that the 9 is in, and the 2 by 2 that's left is 3, 7, -1, 4. Okay? So it's 3, 7, -1, 4. Okay? And if this would have been a -9, then it'd be minus a -9 here. Okay? Okay, then you take the 3, and it's plus 3. You wipe out the row that the 3's in, okay, and the column that the 3's in, and the 2 by 2 that's left is 3, 5, -1, 2. Okay, so we've gone from a 3 by 3 to 2 by 2s. Okay, so 8. Now we're going to use parentheses there. You're going to multiply down the diagonal to the right. Okay, and I recommend you show it. Subtract the product coming back up. So I get 20 minus 14. Minus 9. You multiply down the diagonal to the right, would be 12, and subtract the product coming back up. So it'd be minus a -7, plus 3, multiply down the diagonal to the right, would be 6, and subtract the product coming back up. Minus 5? Check my arithmetic. Huh? Okay. Yep. Okay, so I got 8 times 6 minus 9 times 19. Minus a negative would be plus, and then plus 3 times 11. Okay, so that'd be 48 minus, if you multiply that out, 19 times 9. 171 plus 33. Okay. And then if you simplify 48 minus 171, it would be a -123 plus 33, and you get a -90. So the value of that 3 by 3 determinant is a negative 90. Okay, and that is the method called expansion of minors. You always start with this part up here. You always put the positive, negative, positive. Okay. Okay, the next thing the author talks about is the identity matrix for multiplication. We did the additive identity the other day. We said the additive identity was all zeros. Okay, let's look at the identity matrix. For multiplication. Bless you. Okay, now this is a matrix, so you're back to a bracket. Okay, first row across, this is a 2 by 2. There's 5, negative 1. Second row across is 4, 2. And then we want the identity, and we want to get back to 5, negative 1, 4, 2. Okay. Now, you'd have to play with this a little bit. You might think the identity is all ones. Okay, but if you put all ones in there, you went here to here, if you multiply that would be 1, and this would be negative 1, and that doesn't give you 5. Okay? If you multiply, you need these two to stay, 5 times 1, and you need this to drop out. So this has to be a 0. The identity matrix is actually 1s down the diagonal and 0s everywhere else. Okay? If you had a 3 by 3, if you had a 3 by 3 identity for multiplication, it's going to go 1s down the diagonal and 0s everywhere else. Okay? Same thing, 4 by 4, 1s down the diagonal. Okay? And in the algebra, it would look like this is matrix A, this is the identity, and it brings you back to matrix A. Okay? Then let's look at multiplicative inverses. Okay? First, let's look at multiplicative inverses for reals. Okay? There's that word again. Multiplicative inverses for reals. Remember, reals are everything on the number line. So if I did multiplicative inverses for reals, okay, if 5 was my number, what's its multiplicative inverse? Hmm? 1/5. Okay. Reciprocals, that's another word for it. Reciprocals are multiplicative inverses. You wrote it like this before Algebra 2. In Algebra 2, you probably did this. Right? Right? Okay, because when you multiply those and the bases are the same, you add the exponents. Okay? And that would actually be, it would be like saying 5 to the first times 5 to the negative 1 would be like 5 to the 0. But what's anything 0 power? 1. The only exception is 0 to the 0 power is undefined. Okay, but this is the one we're going to look at. Okay, you're used to this from the Algebra 2. Okay, that's multiplicative inverses for reals. Now let's look at multiplicative inverses in matrices. Okay. Multiplicative inverses for matrices exist only if the determinant does not equal 0. Okay? If the determinant equals 0, then there is no multiplicative inverse. Okay? Okay, let's look at an example. Say they ask you to find the multiplicative inverse of matrix A if A is, first row across is 3, -1, and this is a matrix, so you've got the brackets. Second row across is 2, 4. Okay, it's 3, -1, 2, 4. Okay? Basically, we're going to take matrix A times its inverse and bring it back to the identity. So matrix A is 3, -1, 2, 4. A inverse, I don't know. The identity for multiplication we just said was 1's down the diagonal to the right and 0's everywhere else. Okay? Okay, since we don't know this, we're going to label it A, B, C, and D. Okay? And if we multiply this row across times this would be 3A, go across with your left, down with your right. This would be 3A minus C equals 1. Write that down as an equation. 3A minus C equals 1. Stay with this row, go to the next column. This would be 3B minus D equals 0. Write that out to the side. Okay? Hang on. Write it out to the side. It would be 3B, sorry. 3B minus D equals 0. Okay, now go to the second row. First column, 2A plus 4C. Write that underneath this one. 2A plus 4C equals 0. And the last one, you multiply this row times this column, be 2B plus 4D equals 1. 2B plus 4D equals 1. We have two equations, two unknowns. Okay? Now we need to solve those. Okay, for A, what did this group get? 2/7, I agree. For B, -1/7, I agree. I guess that was part of the other one. Oh, you guys got C. Sorry, you guys got C. What'd you have for C? -1/7. B, what'd you get? 1/14, I agree. D? Huh? 3/14, I agree. Okay, so our inverse would be 2/7. The B would be 1/14. The C would be -1/7. And then 3/14. And actually, this is easier to check than it is to work. Okay? Because you got to end up with this identity. Go this way. This would be a negative, or 6/7, and a positive 1/7 would be 7/7 would be 1. Yeah, that checks. This row times this column would be 3/14, and a negative 3/14 would be 0. Yeah, that checks. Okay, this one to this one would be 4/7, and a negative 4/7 would be 0. Yep. And then this one to this one would be 2/14, and 12/14 be 14/14. Yeah. Okay, so this is the multiplicative inverse. That would be your A inverse. Okay. Okay, now that took you a little while, right? Shortcut. Okay. And you can work it by the shortcut. Here we go. If I gave you the matrix A, same matrix, 3, -1, 2, 4. And I want the multiplicative inverse. Okay? A inverse, and multiplicative inverse you write with the exponent -1, multiplicative inverse. Okay, it's always 1 over the determinant of A. Okay? So first, what's the determinant of A? So you got to figure that. Multiply down the diagonal to the right. If I'm figuring the determinant, would be 12, and subtract the product coming back up. So subtract a -2. So the determinant would be 14, right? It's always 1 over that. So it's 1 over 14. Okay, everybody look up here for a minute. shortcut. The 2 down the diagonal to the right change places. They just change places. Okay? Whatever this sign is, change it. Whatever this sign is, change it. Okay? Now take your scalar times that matrix. That'd be 4/14, 1/14, -2/14, 3/14. So that'd be 2/7. You got to reduce all your fractions. Was that easier than the 2 equations, 2 unknowns? Yes. Okay? It's 1 over the determinant on the outside. The 2 down the diagonal to the right just change places. Okay, so I change those 2 around. Whatever this sign is, change it. They do not change with each other. Just change the sign. Whatever that sign is, change it. Whatever that sign is, change it. And multiply it out and reduce your fractions. Okay? That's multiplicative inverses. Okay? Okay, that's where I'm going to leave off today. Okay?